Thank you for the introduction, and thank you, everyone. Happy to be here and looking forward to sharing this presentation with you today. So, as Cecile mentioned, my name, if I can skip there, is Logan Bailey. I'm a senior consultant with Barrington Consulting. I've been working in the continuous improvement and Lean Six Sigma space for over 5 years now. My background is in industrial engineering, and I graduated with my bachelor's at Dalhousie University. And currently, I'm pursuing my master's in analytics through Georgia Tech part-time. I joined the Barrington Ops team, which is a specific division at Barrington focused on operational and performance services in 2020. And in that time, I've gotten to really work with a variety of industries, including the public sector at the federal, provincial, and municipal level. I've gotten to work in aerospace, finance, healthcare, and even a bit of food processing. So over those projects and over my time at Barrington, I've gotten to use a lot of the Lean Six Sigma tools, and one of which is metric-based process mapping, or even process mapping in general. And so I'm excited to share that with you today, and how it's evolved and how there's some great technology you can use out there for this specific tool. So the objectives for today, I'd like you to understand the concept of a metrics-based process map and how the use of data can enhance your traditional approach to process mapping. I would like you to be aware or be able to complete a simple metrics-based process map. We might not go over all the details of all the different icons, but you should be able to create a relatively simple metrics-based process map at the end of today. And then I'd also like you to be aware of some of the tools that are available to support metrics-based process mapping and how they can be, and how these maps can be further enhanced for process modeling and costing. Right, so the agenda. So what I'm going to do is I'm going to start off with a bit of a background. So I'll take us through some Lean Six Sigma. If you've never heard of it, or if you don't know much about it, no worries. What I'd like to do is take you through a bit of background. I won't spend too much time on it. And then what we'll do is we'll get into the process mapping piece. So we'll look at the traditional approaches, so traditional process mapping, and then we'll compare that with metrics-based process mapping to see what that looks like and see what the advantages are of the metrics-based approach. I'll share some real-life examples that have been completed using metrics-based process mapping. And then we'll talk about how it integrates with business process analysis and costing. And then finally, we'll have some time for some questions and wrap up at the very end. Alrighty, so we'll start off with the Lean Six Sigma background. And before we get there, what we'll do is we'll talk about the 4 Ps of an organizational performance management system. And so this is the 4 Ps are a model that we use in our training. We believe strongly in it. And basically what the 4 Ps mean are the 4 pillars, right, of the organizational performance management system. Those are those outer 4 squares you see here in this slide. The first one is the purpose or the philosophy of the organization. That has to be well defined. That's your mission, that's your vision, that's where you want to go. How you get there is through your people, right? And that can be your staff, your senior management, or maybe even your external partners that you work with. So those people need to know what the purpose of the organization is so that they know what they should be doing to move in the right direction. And that connection is what we call performance excellence. That's your effectiveness. That's doing the right things. And to do those things, the right things, we have to conduct work through a series of processes and policies. And that brings us to our 3rd P down in the bottom right, our process and policies. These can often be technology enabled. And so what we need to do is our people are working in those processes day to day. So that's working in the business. That's our daily management. And then, of course, in order to make sure that we're able to do things well, right, that we're overall efficient, we need a system in place for identifying and capturing improvement opportunities and then acting on those. And so that's the 4th P, the problem solving and identification in the bottom left. or the possibilities of what we could do, right? And that's our operational excellence. That's our efficiency. That's making sure you're doing things right. And that's the key focus of Lean Six Sigma. And so Lean Six Sigma actually is born out of two methodologies. So the first one that we see is Lean. So Lean dates back to the Toyota production system back in the 1950s, 1960s, and it's really evolved over time. And what it is, it's a way of doing business that drives a culture. And Toyota was really set on driving this culture of continuous improvement and service excellence. And so they developed a series of systems and frameworks and tools and principles known as the Toyota production system, which has evolved over time because of the applicability to many industries outside of the manufacturing industry. And so really at its core, what Lean is looking to do is improve the value for our clients or our customers, and those can be internal and external customers. We want to improve the way that we work, so being more efficient, identify and eliminate unnecessary steps, and streamline the process. So we want to eliminate waste, and I'll explain what waste means here in a minute. And overall, we want to enable end-to-end process and performance excellence. For those of you that are project managers out there, or have any PM experience, you might know the triple constraint. Well, what you can see is Lean looking to do is we want to increase our quality and our capacity, and we want to reduce the cost and the time required to do that. So that's Lean. Then we have Six Sigma. So Six Sigma actually comes from Motorola, and Six Sigma does have a meaning. It comes from stats, and it was developed by a set of statisticians at Motorola. And so a Six Sigma level means that you have 3.4 defects per million opportunities. And so that was the standard of quality that Motorola was seeking to achieve. And so over time, what happened is the two methodologies really do go hand in hand. So they actually eventually merged to become one methodology. And the series of tools and principles are now seen as one. And so when Lean Six Sigma is typically used in an organization for a project, right, we typically see some standard things. So before the implementation or before the use of a project, we might see that we're not able to hit our service commitments. So we're not able to deliver enough product or process enough applications or deliver enough grants, whatever that may be, by a certain date. You may also see that our ability to meet our customer requirements is all over the place. There's a lot of variation in the process. We're not being very repeatable. So in essence, what's happening is you might see some underperformance and maybe some even unhappy customers. These usually trigger, in an organization that has adopted Lean Six Sigma, what it does is that would trigger the use of a project so that we can look to alleviate that problem. And after that project is complete, what we would expect to see is we'd be faster and more efficient. So we'd be able to better meet our service commitments. That's where Lean comes in. And we've reduced our variability, right? So our quality has increased. So our ability to meet our customer requirements is much tighter on our target. So this, of course, leads to satisfied customers and overall increased value for the customer. And what we refer to this is we hope to seek and obtain capable and stable processes. They're capable of meeting our customer demands and expectations, and they're stable. They're consistently able to do so. So in the Lean Six Sigma world, there are a series of multiple methodologies that you may have heard of, and that's okay. I'll just provide a quick background on some of them. So the first one on the left is the quick wins. Right? And so these are the simplest of projects. They usually have very little risk. It's something that you can change with little time or little risk, right? We could go do it tomorrow, and if it didn't work out, we could always easily revert back without really any risk or adverse events. The second type of project, which is a bit more complex than a quick win, is a Kaizen event. Some people may call these rapid improvement workshops. And so what these seek to do is they'll seek to bring the team together to dive into the process over a series of a day or a couple days and identify and implement some improvements. So these usually require a bit more conversation and have a bit more complexity or risk than the quick wins, which is why we need the consultation. And then the third methodology is the DMAIC methodology, which you may have heard of before. This is focused around process improvement. These are more complex projects, and we need to go through a series of phases to make sure we truly define the project and then are creating improvements that really do solve the problem and that we're able to sustain. So we're going to focus, I'm going to tell you a little bit more about the DMAIC because it's usually the one people have heard most about and that we see most often. So the DMAIC methodology stands for define, measure, analyze, improve, and control. And each of these are a phase that you would go through throughout a project in order to complete said project. And so this really ensures that we're taking the time, the due diligence to define the project, make sure we truly understand what's valuable from the customer's point of view. What is it that the business needs? What is that voice of the business and the reason we should take on this project? Making sure those two things are well understood so that we can go about completing a meaningful project. Then we get into measure, and this is where we're trying to understand the business processes as it is today. So how is the process currently performing, and how does that relate to the customer requirements and the business requirements as set out and defined? Then in analyze, we try to understand where are the root causes of the issues, or where are the areas of improvement or opportunity that we can seek to act on. Once those are understood, we can come up with a set of improvements and prioritize those, and then deploy and implement those. And then finally, we get to control. And this is where we try to make sure that we sustain the improvements. So we don't want to just implement the improvements and hope for the best. We really want to take the time to make sure that we sustain the change and that we're not going to revert back to our old ways once the project is completed. Okay, so what this seeks to do is take us through a defined set of phases so that we can complete the project in a meaningful way. Right? And so what we're trying to do is we're trying to drive value for the customer. Right? And so one of the typical things, and we'll talk about this a lot when we talk about process mapping, the ways that we can do that is to eliminate waste in the process. And in the lean world, we use this fun acronym called TIMWOODS to help us remember the 8 different types of waste. And so essentially those are transportation, inventory, motion, waiting, overprocessing, overproduction, defects, and skills, a lack of skills. So I won't go through all of these in detail, but essentially what they are is they're cues or they're things that we look for in our processes, specifically when we're doing a process map, that we might want to seek to remove or improve upon so that we can drive more value from the customer. And so these are things we're going to want to look at as we get into our process maps. So when I talk about waste, I'm talking about these 8 different types of waste here. Okay. So now that we've talked a little bit about Lean Six Sigma, and you've got a bit of background on that. What we're going to do now is we're going to jump into process mapping. And so I'm curious, maybe you can all let me know in the chat, has anyone had any experience with creating process maps or? Oh, okay. Oh, yes. Okay. We've got, yes, Dragos. Okay, yeah, great. So we know lots of process mapping, it seems. That's great. Or at least we have some experience, it seems, from those who have responded. So that's fantastic. For those of you who haven't, sorry, I'm jumping ahead here. Process mapping is it's a tool in the Lean Six Sigma tool belt, but it's not only used in Lean Six Sigma. Other methodologies and many organizations complete process maps. And what it is, it's a way to define your process. And often in Lean Six Sigma, in the measure and analyze phase, the earlier phases of the project, it's a way of documenting and understanding the current state process, how it exists today, right? Not how we want it to exist, but how we complete the series of activities and who does those activities in the business today. And so what this allows us to do is understand and find where are those areas of opportunity, where are the wastes that we might seek to remove so we can provide more value to the customer. So a couple key points about process mapping. We really want to show who and what is involved in the process. So we want to define the key activities and who is responsible for those. We like to do this visually. So rather than writing out an SOP, process maps are a visual indicator of what the process looks like. And this is the benefit of when done with the group, they can clearly see the process that exists, right? They can build it with you. But it also clearly shows anytime there's a loop back, if there's a bottleneck or multiple streams condensing down to one, or maybe there's multiple decision points or levels of approval, that becomes very apparent when you look at a process map. So we like to keep this visual as it makes these things pop out, which might otherwise be hidden in an SOP. One other thing that we say is process maps should contain in-process performance and quality indicators, right? If you're familiar with the idea of lead and lag indicators, hopefully these indicators are lead indicators in the sense that they tell us an indication of how we're going to perform at the end of the process. And so these are some of the things that we often do see missing from process maps, and that's okay. But we do generally encourage you to include them if you can. So when you think about performance indicators, those are usually a measure of time, cost, or the output for the overall process. And then your quality indicators could be a measure of your defects, your rework, or your scrap for your overall process. So there's some key points in mind when building a process map. Of course, in the traditional process map, with the traditional process maps, there are lots of different types. And so you may have seen one or many of these, and you may have a preference, and that's okay. Down here on the bottom left, we can see process flow map with phases and integration points. So we can clearly see that someone's taken the time to color code by phases the series of steps. We can see just a plain process flow map here down in the bottom right, where we have a series of activities flowing into each other. And then of course we have the one up here, which is the cross-functional process map, sometimes referred to as a swim lane process map. And so what we have here is we have each of the different swim lanes, right? If you think of this, it kind of looks like a swimming pool with the lanes in it. So in this lane, we know exactly who is conducting those activities, all right? And so in these traditional process maps, we do like to build them with the team. We don't want to do this on our own. We want to go to the team, go to where the work is done, and really map the as-is process so that we can get a good understanding of how the process is working today. Right? We think that measure, analyze, how are we doing today? However, the other thing that's missing here, right? So this tells us, what activities are happening. We can clearly see who's doing what and when and how they flow into each other. But what we can't see is some key pieces of data, right? I don't know how long each of these activities take. I don't know, is there a big wait time? Do we have a big buildup of inventory? Right? These are good metrics that we might want to include in our process when we're trying to assess where is the waste? Where is the area of opportunity? So although traditional process maps are very helpful for visualizing and understanding the process, we can take these a bit further by bringing in some data. So hold on to that thought, and we'll get to that when we get to the matrix-based process mapping. But before we do, I just want to show you a little bit bigger picture of a traditional process map. Although some of you mentioned in the chat that you have lots of experience, not everyone chimed in. So just for those of you who maybe don't have quite as much experience, right? So again, this is that swim lane or that cross-functional process map. We have some information about the process at the top here. What's the process? Who is the owner? And then we have who are the stakeholders involved in that process? And as you can clearly see from this very simple example, right, we have a starting point here at the top left, and we have a series of points where this process may end. And in between there, we have a series of steps and activities that take place before we reach the end of the process. We typically use process map terminology or specific icon set. These rectangles indicate a step in the process. Anytime you see a rectangle with these additional lines down it, that may indicate that that's a sub-process. So there could be a lot of steps involved here, right? This might have its own process map of its own, but it may not be relevant for the process map that we're looking at. And then we also have these decision blocks, and these are our diamonds and what they do is they allow us to see, can the process split? Can it go in different ways? This could be an approval. Was this approved? Yes, no. This could be around a different application type. It could be around a different product, a different grant request type, whatever that may be, right? It may go one way if it's a certain type, and it may go another way if it's a certain type. There are other icons in the typical process map icon set. I'm not going to go over them all today. If you know those ones there, you should be able to build a relatively simple process map that can visually describe your process. Now, let's take this a little bit further. Let's talk about metrics-based process mapping. Okay, so a metrics-based process map is exactly like a traditional process map, with the key exception that we bring in data. Right? This allows us to do a couple things. And so let's first define what are some of those metrics that we bring in. And so the first one is the processing time. And you can think of that as the hands-on time spent on that task or activity. We have the elapsed time, which is the total time from the start to the finish of an activity. So that allows us to capture if we may not, I may start something in the morning, but get back to it in the afternoon. So there's a longer elapsed time before I can finish that activity. We may have some waiting time in between steps, and we'll bring in a complete and accuracy rating. So that's a measure of our quality. How often is that step completed perfectly the first time without any rework? So if we think of a process, right, what do those actually look like? We have a series of activities. What is it that we do? We complete a site visit. We might have to do some information queries, pulling some information, and then we might do some reporting. And so if those activities happen in a sequence, then what we want to do is to understand what's our total time to finish that process. So this process is very simple. It's only 3 steps, so this should be pretty simple to look at. So the first thing we might have is the elapsed time, right? So I might start this site visit today, but it'll take me 2 days before I finish it. Same with the queries, and then reporting a little bit longer. However, within those 2 days at the site visit, my processing time might not be quite as high, right? I might only spend 450 minutes on that actual site visit. So that means there's a lot of time where I'm not actually working on that site visit. That might be me working on a different product. That might be conducting a different site visit, doing some different activities in my job, whatever that may be. And then of course we get, my animations aren't quite working there. There we go. So then we get some wait time, right? So we get some wait time in between our activities. So we can see, well, there's a 12-day wait from whenever the initial request is sent until I complete that site visit, which takes 2 days. And then there's a 4-day wait after I complete a site visit before I complete that query, which takes about 2 days. And then there's another 10-day lag before the 4 days of reporting. So what you can see down below are some summary metrics here. And so the total elapsed time where I've actually worked on the product, right? That's that 2, and that 4. That's 8 days. But of the processing time of those 8 days, right, of the 450, 180, 720, I've only actually spent 3 days working on that process. Now, when you bring in that waiting time, right, that 12, 4, and 10, that means our lead time, our time to serve, is really 34 days, because we have 26 days in waiting time, plus the 8 days of elapsed time. So that means from the initial request to when this process can be completed is going to be 34 days. This also allows us to look at the value-added ratio, which is a form of benchmarking. And what this allows us to do is look at the industry standard, depending on the industry you're working in, to see what that value-add ratio should be. In this example, it's 9%, meaning of the total time, 34 days, that lead time, only 3 days are spent actually working on that product or service. So that's a 9% value-add ratio. So as you can see, if we had just looked at this process as 3 simple steps, right, it wouldn't really tell us all that much. But as soon as we bring in this data, right? We bring in the processing time, the elapsed time, and the wait time. We're able to learn a lot more about this process. We can see where the big bottlenecks are. We have a 12-day wait here. We can see we've got a big gap between our 2 days of actual time working on this process step versus the actual time required, and so on. So this allows us to see a little bit further as to where those area of opportunities might lie. Right, so that's of course going to highlight where the bottlenecks are. As we saw in that previous example, we saw a 12-day lag time at the very front, so that could be a bottleneck. We saw that can also highlight the waste, right? If we think back to Tim Woods from the Lean Six Sigma methodology, anytime we see a big lead time in between steps, that waiting time, that usually indicates that there is an inventory buildup. We see waiting, right? So waiting is time spent waiting around for the product or service. So bringing in those times really allows us to see that. And then we might even see some overproduction or overprocessing. My example didn't include any of the defects, the complete inaccuracy, but I'll show you that here on some examples coming up in a minute. Bringing in the metrics also allows us to understand our total lead time. What is that time to serve, right? So that's important. If we have any service standards or service commitments, maybe that's within departments, or maybe that's to our clients, that lets us understand how we're performing in relation to those service standards. It allows us to understand our value added ratio. As I mentioned, there are industry benchmarks for different, depending on where you're at. And so by looking at your process, what you can do is understand where you are in relation to those benchmarks and whether or not you're on the leading edge, or if you're lagging behind and you might need to do some process improvement. It can sort of identify some resourcing issues. If you're seeing a big buildup in between before activity, it might be an indication that there's a resourcing issue. We can actually further enhance metrics-based process mapping to really get to the resourcing issues. And of course, within a process map, it can identify those loopbacks or any quality issues. So I'll take us through a couple of examples. So the one I have on the screen here is an example from Eden Valley Poultry. They're a poultry processing facility in Berwick, Nova Scotia. And so we've done a number of projects with them over the last couple of years. And the one in the back left was around their inventory management of their packaging products. And so what we did is we gathered the team, and you can see all the stakeholders here. We had operations, we had Nathan, which was the individual who's in charge of tracking all of their inventory. We had a couple other individuals here as well, Rick and Colleen. We had QA, CFIA, and sales. And so we brought the team together and we created this metrics-based process map. And now I will say the metrics for this one, we actually logged on a spreadsheet as we went, just because we didn't have a lot of space here in the room that we were in, so we didn't want to make this too cluttered. But what it allowed us to do is really understand where were the bottlenecks and where did we see the wait times in the communication of the information that was required to get a PO out. And so by doing so, we were really able to understand their process and reduce that lead time so that they could get the products that they needed to package the chicken in on time. Another example, and this is just a small example here, it is cut off, was for their production processing. And so you'll see what we did is we created a metrics-based process map. And for this one, we captured not only the metrics, which are actually at the bottom of this example, but we also captured the inputs and the outputs. So further expanding even some of the information we would normally capture in a metrics-based process map to understand what spreadsheets, what tools, what systems were they using to track information. So we used some different color coding icons and some examples of what they were using and what they were pulling in each of those steps to understand how information was flowing. Another example was with Efficiency Nova Scotia, or Efficiency One. And so for them, what we did is we conducted a rapid improvement workshop. And so in this example, they were implementing a new system. And before doing so, they really wanted to take the time to streamline their processes. Otherwise, they were going to have to do custom development within the system to meet not so streamlined processes, which is never a good idea. You should always streamline your processes before doing a new system implementation. So that's what they did, and that's what we helped them with. And so what we did is, again, we got the team together. So we had our stakeholders down here on the left, and we brought them together and we completed this metrics-based process map over the span of a morning. And you'll actually see at the bottom, again, we had the metrics in a timeline view here. And they actually had two different types of applications that they were going through this process. And so we just used it, because they followed the same process, we were able to just use different times, different processing time, different elapsed time, different complete and accuracy ratings, and different inputs and outputs along the bottom here. So what we were able to do from this was identify some improvements, and then, of course, go on to implement those improvements so that when they did implement their new system, they had streamlined processes that were much easier to implement into their new technology. And then the next example here is not a project that I specifically did, but I have another example, an extension of this that I really do want to show you as how you can take metrics-based process mapping even further. So this is an example with Nova Scotia Crown Lending. And just like the examples you saw before, what we have here is a metrics-based process map. So along the left, right, where we have each of our activities, which is the processing time, the elapsed time, and the complete and accuracy rating. We have the labor resource. We have the person who is responsible for that activity. And so that you can see that each role in its swim lane, right, clearly has those activities. So we can visually see that just by looking at this metrics-based process map. Now this data here, right, is that's what's the key data for our metrics-based process map, so we can really understand where are those bottlenecks and where are the waste within this process. Okay. Now, we can actually take this a little bit further. So as was mentioned before the presentation, although metrics-based process map is an enhancement to the traditional process mapping, you can take that even further, and it's really the predecessor to doing any sort of business modeling or simulation. And so that's how it integrates with business process analysis and costing. So, right, just like in our metrics-based process map, we have our process activities. So we have the information we went over before. So we have our, elapsed time, we have our processing time, and our wait time. So we collect that information just like we would have before, except what we do when we want to take this a little bit further is with business process analysis and costing, what we can do is we can really capture a little bit more information and take it further to truly model this process. So what we can do is we can bring in the customer demands. So, these could be, different types of loan applications, or these could be different types of chickens with Eden Valley Poultry, or different types of products, right? These are your demands that go to your activities. What products and services we supply, those are really your demands. And to complete those, right, you have to go through a series of processes. And now if we take that up a level, right, we go up, what we can do is look at if we have our demands and we know the total processing time, right, the hands-on time required to complete that activity, what we can do is we can actually model the utilization. What's the percentage of our available capacity of our resources? So in this example, this could be our field team, or of any equipment that we might actually have. And that could be additional equipment or assets, or that could be building or other assets such as that. You can even take it as far to include external contractors or external partners. So this allows us to understand what is our utilization. And then if we bring in the financial data of those resources, what we're able to do is actually able to calculate our cost to serve. So you can actually work out what is your cost per unit of work. So that could be, your dollars per call, your dollars per report, or you can take it down to the demand level. What is the cost per unit of output? Your dollar per assessment, right? So this business process modeling that we're doing with BPAC really stems off well from the metrics-based process mapping, right? a lot of the inputs, your processing time and your complete and accuracy rating, if that involves extra rework, right, those activities can also be modeled into this process model. And so that's why it's a predecessor to doing any sort of process modeling or simulation. So to show you that and show you what that looks like, what I'm going to do is I'm going to pull back up. This is that Nova Scotia Crown lending example that we saw earlier. And this is actually built in CBP. So that's an application built on Qualiware, as I'm sure many of you know. And so what this is that metrics-based process map that you saw on that whiteboard with sticky notes, but this time it's actually been built into the application CBP. And so each of these activities you can think of as a sticky note, okay? And it has a processing time, it has a lead time or elapsed time, and it has a complete and accuracy rating. It also has the labor resource, so that's the, think of your swim lane, the person or resource that is completing that work. And then of course we can even bring in the number of staff in that position and how much capacity each of those individuals would have, so that we can do that process modeling. And I will say, as a quick aside, Mike and I have actually been doing, we completed our most recent workshop with Veterans Affairs using CBP as the modeling tool. So we did that right away. We actually didn't use, we didn't use Visio, we didn't use Sticky Board and Whitenote. We actually built the value stream map for the metrics-based process map as we went, right? So we did this in CBP live during the workshop. And Mike, I'll let you comment at the end there, but I actually think it went quite well. So as you can see, the benefit, of course, to doing this in the software is all these calculations, this timeline here, the total processing time and the lead time, your total lead time, your total processing time, that value added ratio, and even your roll throughput yield, which is just a, the product of all of your complete and accuracy ratings. So that would be a measure of how often an application or a loan is going through this process, complete and accurate without any rework. And that's only 7%, so that's quite low. Keeping in mind, this is all demo data. This is not real data. And so this all comes in together and allows us to do that business process analysis and costing. We can fill in some of the extra information, so the demands and the financials, and that really allows us to use our metrics-based process mapping as the backbone for business process analysis and costing. And of course, this is great because we can take this data and we can do all sorts of what-if analysis, and we can run lots of different simulations and understand, oh, well, if we were to change who does this activity or add a resource here, then what's the outcome of that going to be? And of course, we can export all that information into a BI tool like Power BI here, and we're able to break down, for a specific type of loan, what percentage of time is being spent on that actual, on those loans by labor resource, or we could even break it down to the activity level and see how are our resources time being spent on each of those activities. So I hope that's a quick demo. I'm looking at the time here, and so I'm gonna try and wrap this up, but I hope that you can see that metrics-based process mapping is truly an enhancement to traditional process mapping, not only from understanding where the areas of opportunity is, but it also enables you to do this process mapping or process modeling and costing, which takes this to a whole new level. It really does allow you to understand what would the projected benefits of these improvements be, which of course can help you build your business case if there's any capital investment required for those improvements, and really prioritize and understand which improvements you should focus on. Okay. That's a bit of a taste of how that all comes together. I haven't mentioned this already, but if you do want to learn more, there are a couple of training opportunities coming up. So you can, if you're interested in these, I can send out the slides, which have the links to each of the courses here above. But we have the Enhancing Lean with Business Process Analysis and Costing. So we'll take you through the techniques and the methodology that Mike and I have used. And That's on December 14th to 16th. It's 3 consecutive half-day sessions, so those are in the afternoon. And of course, there's also the CBP modeler and the implementing business process analysis and costing. I won't go anymore because I'm definitely at the end of my time looking at my timer here, and I know that Kevin mentioned these already, so I'll wrap it up.
Thank you very much, Logan, for your time. Really appreciate it. Very interesting topic, and really appreciate you joining us today.